Hello, algebra students. Well, this is section 6.5, dividing radicals, and we've already added, subtracted, and multiplied, so now it's time to divide. Notice this note, just like with multiplication, you have to have the index the same to multiply. Well, you also need to have the index the same to divide. Okay? So here's the steps. Divide the coefficients and then divide the radicands, any numbers and variables that are in the radical. Subtract exponents on like bases when you're dividing variables. That's how you do that. And then cake to simplify. So it's a lot like the steps to multiply. In that case, we multiplied the coefficients and we multiplied the radicands, and when multiplying, you added the exponents on like bases. So note this rule over here, and that's really what makes the whole thing work, is the quotient of square roots is the square root of the quotient. So you can actually put the square root symbol or any radical around the entire quotient, and then you are dividing the whatever was in there, dividing the radicands within that radical. So it'll help to look at some examples if this seems a little fuzzy. Let's look at these. So the first one, we're going to divide the coefficients. And there's nothing out front to divide. Everything is inside the radicand. So we'll divide, or everything is inside the radical. We divide the radicands, numbers and variables. We have 18 divided by 2. That's 9, and that's inside the radical, right? So that's 9. And then we have x to the 5th divided by x to the 3rd. Well, that's x squared, and that's inside as well. So now we have to cake this. So for 9, of course, we have a pair of 3s. We have a group of 2 3s. We have a 3. So there it is. One group of 3s. So it's a 3 that comes out. What about the x? We have a group of 2 x's as well, right? X times x. So x comes out. And there's nothing left. There's no leftover x's. There's no leftover numbers over here in our cake. So that's it. We're done. Nothing inside the radical, so you don't even write the radical. Okay, let's look at the next one. So this is cube root. We divide the numbers, we divide the radicals. There's nothing outside again to divide. Inside it's 162 divided by 3. That's 54. And that is, of course, inside our radical. Everything's going to be in it because there was nothing outside it. 162 divided by 3 is 54. And y to the 5th divided by y squared. Subtract. So 5 minus 2 is 3. Okay, so this is something that we can simplify. So we use the cake. 54. We'll use 2. Get 27. And then we're using 3's after that. 27 divided by 3 is 9. Divide that by 3, you get 3. And divide that by 3 to get 1. So groups of threes, yeah, we have this group of threes. It's 3. So that means we have 3 outside. And in the variables, we also have a group of 3. It's the y. Y to the third power is one group of 3. So since there's only one group, you have one y on the outside. What's on the inside? Well, there aren't any y's, we just said, on the inside, but there are numbers. And the number that's left is the 2. Right here, right? It's not in any group, so it goes in there. Okay? Okay, the next one, we divide those radicands. This time I'm going to go ahead and show you. Remember, we said this whole thing works because the quotient of radicals is the radical of the quotient, okay? Whatever root we're talking about, third root, square root, whatever. So this is the square root of this quotient. So you have a big square root symbol that has the whole thing inside it. And that's what's going on here. We haven't been writing this step down. We've just said, well, divide the radicands. But when you put it all under one radical like this, you can see why we divide the radicands. Because it becomes just a division problem inside a radical. So 125 divided by 5 is 25. And this is inside the radical, of course. And then x to the 4th divided by x. Subtract exponents, so you get x cubed. And then y divided by y to the third is subtract exponents. 1 minus 3 is negative 2. So you have y to the negative 2 power. Now what do we do with that? Well, negative exponents means 1 over y to that power. So it's 1 over y to the second. But remember, that is inside the radical. So this time we're going to split that apart, though. Remember, this, I'm going to go ahead and show it. You don't usually have to write this. You don't have to write this down, but yeah, what we really have here is that's in the numerator, and the denominator is y to the second. That's what the negative exponent means, right? You put it in the denominator and make it positive. So when we see that, we say, okay, we need to split this back so we can deal with that y to the second power in the denominator. So you can put the radical around the quotient, but you can also break it back up this way. You can go either way, okay, because it's equal. All right, so that's just about it. We can now simplify the numerator and the denominator. Okay, so look at that numerator. We know when we take 25, it's going to be 5 times 5. That's a group of 2 5s. So the 5 is going to come out. 1x will come out, right? Because in x to the third power, you have x times x to come out. You have a group of 2 x's, so x comes out. And then you also, though, have inside the radical an x, right? Because there's a leftover. The denominator, we just have the square root of y to the second power. So there is a group of 2 y's there. And So we bring out a y, and that's it. There's nothing left over. So that's the denominator. Okay, so that is it. Let's see, I didn't draw a box around this one. I always remember that. Okay, so you don't have to write these intermediate steps. You know, we did not have to write this because we knew we were going to take 125 divided by 5 and get 25. So we could have gone straight to that, okay, without writing this intermediate step here. Similarly, over here, I wrote this step just to show that, yeah, we're going to break it back into two of them. But we could have gone straight from this to that, because we know the negative exponent means it goes in the denominator, and we know once it's in the denominator, sure, it can split into two radicals. Again, that's because of this property right here of radicals. Okay, you can start with this one and go to this one where you split it up, or you could start with this one where you have the quotient of radicals and then rewrite it as that, whichever is the handiest that you want to do to accomplish what you're trying to do. Okay, so let's go to the next one. So we divide the coefficients, so divide 14 divided by 7, that's 2. And then inside the radical, we divide 50 divided by 2 is 25, divide the numbers, divide also the variable, x to the 7th power divided by x to the 2nd power, subtract exponents, that's x to the 5th. So now we want to simplify that. So let's see, 20, oh, I wrote this down. No, I didn't. I wrote it right. Okay. The 25, we take that. It's pretty basic, right? You're going to have 5, and you're going to have 5. And that's it. So you do have this group of two 5s. So 5 comes out. And so that's 2 times 5, because we already had a 2 out there. Inside the radical, oh, with x's also, sorry, we have groups of 2 x's. It's groups of 2 we're looking at because our index is 2, of course. So we have 2 groups of 2 x's. So we have x squared out here, x times x, and then a leftover x inside. Whoops. Okay, and we will simplify that a little more just by multiplying that 2 times 5. That's 10, right? 10 x squared times the square root of x. Okay, we'll just have one more. Okay, so we first divide the numbers out front. 8 divided by 4, so that's 2. And then we're gonna, there's no variables this time, but we take 6 divided by 24. Well, that's a fraction this time. Okay, and like, look at the one we did above, D, we had 50 divided by 2, that gave us 25, not a fraction. We just put that 25 in the radical. But this time we get a fraction. So this time we really, to make the most sense of it, I think to make it easier, we need to go ahead and write that inside the radical as 1 over 4 inside. Okay? So we have 6 over 24, and that's 1 over 4. And we write it inside the radical. Okay, so that is the same as, of course, 2 times the square root of 1 over the square root of 4. See, that's what helps us to simplify it, because we can do those. We can write what those are. In the numerator, square root of 1, well, that's 1. And then the denominator, the square root of 4, well, that's 2. Okay, so we get 1 is the answer. Okay, so that's all the examples we have. That should be pretty representative of what you have on the worksheet, although we do like to change it up a little bit. There might be some that just a little bit different, but hopefully this will get you going on it. Well, that's all for now.